Electromagnetic waves. To first understand electromagnetic waves, we start with the visible light that we can see. So we can see red, orange, yellow, green, blue, indigo and violet light. And that makes up what we call visible light. Now, the difference between red light and yellow light and green and blue, the difference between these is their wavelength. They are all waves, but they have a different wavelength. And actually, the further towards the red you get, the longer the wavelength. The further towards the indigo and the violet you get, the shorter the wavelength. So we can imagine there's like a wave passing through here, longer wavelengths here, shorter wavelengths here. Now, the electromagnetic wave, or the spectrum, actually is wider than just visible light. And we start with things with very long wavelengths over here. And the wavelengths gradually get shorter and shorter so we get some very short wavelengths indeed. But visible light is just that sits in this range here, just the part that sits in this range here. So here we have visible light. And that's all that we can see of this whole continuous spectrum of wavelengths, long wavelengths all the way to very short wavelengths. We can see the visible light. That's it. However, that's all there. Okay? That's just a bit that we can see. If we could see wavelengths that are a little bit shorter, then we'd be able to see here, beyond here, we have what's called ultraviolet light. Ultraviolet light, or UV. And if we could see longer wavelengths still, we'd be able to see X-rays. And further on, gamma rays. But we can't see those. Our eyes aren't made to see those. Some animals, like bees, can see ultraviolet, and there's some cool films on the internet showing bees hunting using ultraviolet. I say hunting, finding plants that utilise this ultraviolet light, but we can't see that. If we go the other way, to longer wavelengths, we get infrared, and further along still, microwaves, and further along, radio waves. And this is the order of the electromagnetic spectrum, or the different electromagnetic waves on this spectrum. So it's a continuous spectrum, but we say ones that have this kind of wavelength would be radio waves, ones that wavelength about here, microwaves, and so on, so on. And this is the range we can see. You get some animals, snakes, can see in infrared. They hunt using infrared. But this is generally what we see. Some animals can see here, some in here, but these are things that we utilise and we detect using other means. Okay? Right, so key thing to note, this end, long wavelength, long wavelengths, and towards this end, short wavelengths. Long wavelengths going towards shorter wavelengths at this end. And just as we've got long wavelengths here, short wavelengths here, we can actually also think of it in terms of frequency. Here, at this end, we'll have high frequency waves. So gamma rays are the highest frequency, high frequency. And down here, we have low frequency. Right, already on here, there's a lot you might be asked in an exam. You might be asked the order of these. You might be presented with this, and they might cover one or two and ask you which ones go in the gap. They might ask you questions like, between infrared and X-rays, which of them has the longest wavelength? Well, infrared is further down here, so that would be infrared. They might ask, if you compare microwaves and infrared, which of these has the highest frequency? Well, infrared is further towards the high frequency end, so it would be infrared. The other thing we need to know about these electromagnetic wave types is some of their uses and some of their dangers, potential dangers. So let's go in order and let's start with radio waves. For each of these, I would encourage you to try to remember two uses. So let's start with radio waves. The first one to remember, and I think the most obvious one to remember, is for radio communication. How your signal gets sent to your radio is using radio waves, radio waves. Okay. And also for your television as well. Also used for television, to send your television signal. There's our radio waves. Just pop that in a box. Now, there are no known, confirmed dangers, or none that we need to learn for our physics paper from radio waves. Microwaves. First obvious use is for cooking food. Now, make sure, although we'll use them in microwave ovens themselves, make sure you say it's for cooking food. That's what we use a microwave for, a microwave oven for. For cooking food. And also microwaves are used for communication, but specifically satellite communication. Now, the advantage microwaves have is microwaves can get through the atmosphere, get up to a satellite above the Earth, be beamed back down through the atmosphere at a different point, okay? Whereas radio waves can't get through the atmosphere. So microwaves are used for satellite communication. So there are microwaves. Again, microwaves, no particular dangers we need to be aware of for our exam. Perhaps a risk if you're cooking food, you might burn yourself, but from the microwaves themselves, no particular dangers. Infrared. Infrared, not infrared. Okay. These, again, used for cooking food. The classic is within your toaster. If you ever look inside your toaster, don't ever put your finger or anything inside a toaster. There are live cables in there, but live electric cables, those, you'll see them glowing red. They are using infrared radiation. It's the thing we most usually refer to as being to do with heat, associated with heat. So again, cooking food, maybe on your toaster or under your grill, you'll see it glowing red. Now that's not infrared that you're seeing, that's a little bit of the infrared or a little bit of the waves that have crept into the visible light, okay, that you can see. Electrical heaters, have you ever seen those bar heaters? The red parts to them, the red glowing parts. Electrical heaters. And also, and this one's hard to draw, they're using infrared cameras or thermal imaging cameras. So you know what? I'm not going to draw that. They're used in infrared cameras. Now, the thing that we do need to note for infrared is actually, because it's used for cooking food, because it's used in electrical heaters, it can cause burns. There's our risk. Let's pop that in there. The warning box there. Can cause burns. So infrared, let's pop our box around that. We've got at least two uses then. As I say, for each of these, try to remember at least two, or two of them, I would say. Okay. So radio waves, microwaves, infrared. Now visible light. Having said, try to remember two. Well, visible light are used for things like communication with traffic lights, signals, lights like that. But one of the other things is also with fibre optic communication. So, Fibre optic communication has these long, fine cables, and these can travel for miles and miles. They've got these going underneath the oceans, and you can send signals down them, and they effectively reflect all the way down the inside, a signal that you send, and will come out the other end. But it's what we call fibre optic communications. Some of you might have fibre optic broadband. That's using the same technology. So small strands, they're actually clear strands, very, very fine, like thin like hairs actually, and signals are sent down those. You might also want to know things like traffic lights as well, that kind of thing. Fibre optic communications, lights. So when we use lights to signal, dangers with visible light, where hopefully you know you mustn't ever look directly at the sun. Okay, so very bright, very intense visible light can damage eyesight. Very bright or high intensity can damage eyesight. So there's our warning for that one. Very bright light can damage eyesight. Let's pop a box around here. That's visible light done. The one they most likely to ask about, I suspect, is about fibre optic communications to do with light, to do with visible light. But remember, any lights that might be used as signals, anything that you can see, you need to think about, right, that's probably to do with visible light. Okay. Ultraviolet. A few uses for ultraviolet. One of those could be in sort of sunbeds. And you might have a tanning salon. And you can see, if you can see it, it's not ultraviolet. But some of the ultraviolet light might be going into the visible violet part of the spectrum. Okay, so that's why we can see them with their sort of pinky purpley glow sometimes. But they're used on for tanning, sun tanning. And that's no surprise, because actually the sun itself gives off lots of ultraviolet light, UV light. You've probably heard it referred to as, and that actually is what tans your skin. Okay. Another use for it is in security marking. So sometimes you might have or you might be lucky enough to have, say, a £20 note, and hidden on there might be a little image that you can only see under a UV light. That would only be revealed under a UV light. So also used for security marking. And you can get some pens as well, UV pens that only glow up under UV light, so you can write on things like your bikes and things like that. And then if they are taken by somebody, the police might find that bike, they can put their UV lamp over it, and they will see where you've marked it with your pen. Should glow up, and they can see your name, your address, and hopefully return it to you. A few more risks with ultraviolet. Now you'll notice the further we go up here, generally the more dangerous these become. We've got risks of burns here from infrared, but generally up here the more dangerous. And actually the higher the frequency, we could also write the higher the energy these waves have. And hence we start to get some more dangers. Now you can have a really high intensity microwave, but it tends to be the higher the frequency, the more danger associated with that particular wave. Okay. Right, so ultraviolet can cause skin cancer. In an exam, you'll be expected to refer to skin cancer, not just cancer, for ultraviolet. Now, if you think that's to do with the sun tanning and to do with UV, That's what can cause skin cancer. You need to remember it's skin cancer, okay? And also can cause premature aging of the skin. So, too much time under the sun, risk of skin cancer, okay? Hence we wear sun cream, hence we try to cover up, and also can cause premature aging. Too much time outside, too much time in the sunshine without having some protection on. So let's put a box around our dangers as well. And finally, and these two, I say finally, but we've got two left, these two we can class together. X-rays and gamma rays. As they have very similar uses and very similar dangers. Now, one thing we use X-rays for is obviously for medical imaging. It's hard to draw an X-ray image, so we'll give it a try. So you go into the doctors with your arm hanging off, and they take an image, and maybe this is what they show of what's left of your arm there after your accident, whatever you've been up to. Now the rest would be dark like that, but you'll see where your arm is. What I'm trying to indicate there is some kind of bone that's definitely been snapped in half there. Okay, so there's an X-ray image, and what we would say is medical imaging. So both can be used for medical imaging, not just X-rays, but there's other imaging they can do as well using these to get more detailed and almost like build up three-dimensional pictures of what's going on inside your body as well. So that's a really good use actually, really important use. Although I said these are the more dangerous ones, these ones have got some very important medical uses and also for medical treatment. And you may have seen machines like this maybe on the telly, perhaps from your own experience, but you get these treatment machines which can be used for treatment, and sometimes there's machines that look similar used for scans as well, so inside a hospital, and they can use these to help to treat cancers. So somebody might be on one of these beds and slide into one of these large round machines, and what we would say is they're used for medical treatment. Note that's different to medical imaging. This is part of the diagnosis, finding out what's wrong with you, diagnosis, medical imaging. This is part of the treatment. So it can be used to treat cancers. They use these X-rays and gamma rays. They're very high energy, and if targeted, they can damage cancerous cells, and that would be good news. Unfortunately, they can also damage our cells, and they, in and of themselves, they can cause cancer. They are what we would call an ionizing radiation. Ionizing radiation. Now, ionizing, if you make something an ion, you mean it's either gaining or losing electrons. Now, in the case of these, if these are you're exposed to X-rays and gamma rays, there's a risk that they may knock electrons off of cells in your body. Okay, and that it can cause cancer. Can cause cancer. So, can cause cancer, but can also be used in the treatment of cancer. And there we have it. So, 1, 2, 3, 4, 5, 6, 7 types, 2 uses for each, and the dangers that we need to know about and we might be asked about in our exams. That is our basics on electromagnetic waves.